Chapter 3, Exercise 17. Show that the composition of two single-rooted sets is again single-rooted. Conclude that the composition of two one-to-one functions is again one-to-one. Now, first of all, I'd like to apologize if there's any background noise. I am doing laundry at ungodly hours in the morning again. There's no helping it. I'm sorry. I hope it doesn't wake up the neighbors, but more importantly, I hope it doesn't impact your viewing experience too negatively. With that said, let's get on with the problem. And let's show single-rootedness holds in the composition. So let's recall what a single-rooted set is. It's very similar to the definition of a function. So a set R is single-rooted if and only if for all y in the range of R. Oh my god. Shut up. Okay. There's all the noises happening today. Unique x in the domain of R such that x comma y is an element of R, or x r y, however you choose to use the notation, that's totally fine. Right. And it's very similar. Recall that a function has basically these statements flipped. So for all x in the domain of R, there exists unique y such that this holds. And again, just to get the definitions clear, a function is one-to-one if and only if it is single-rooted. This just follows from the definition on page 43. It is a single-rooted. So this is in page 43. Alright. So, yeah, let's just compose some single-rooted sets. Okay. So let's suppose R and S are both single-rooted sets. And I don't know if we've actually worked with a composition of two different sets. So let's recall that the composition of R and S, denoted by R, circle S, is going to be equal to the set of U comma V, such that there exists some T, such that U, hold on, I always get this one wrong. I always get them flipped. So let me just not lie to you for a second and look up the actual definition. Right. So it's going to be UST and TRV. Now, in functions, these are not necessarily functions, right? We're only working with single-rooted sets. But in functions, it looks like this. R compose S is equal to S, R of S of U, for instance, right? Which should be equal to R of T, which should be equal to V. So this is equivalent to saying that R compose S of U is equal to V. Right? So there's some intermediate value such that this holds. That's what the formal definition is trying to say. Right. So, yeah. If R and S are both single-rooted, then we're going to show that this set is also single-rooted. So since, or rather, let's suppose U comma V is in, or rather, no, that's not the right way to do it. So suppose B is in the range of R compose S, right? Then there must, I swear all my alarms are going off and I am so annoyed. Can you shut up? Thank you. Okay. Alright, this is sensory overload. Alright. So, suppose V is in the range of R compose S, then there exists some U in the domain R compose S such that U comma V is in R compose S. Okay. So now we're going to show that this U is unique, right? So now suppose that there exists some W, some different W, or maybe just some W. Such that WV is an R compose S. Okay. So now we want to show that these two are equal. Right? Now, UV being an R compose S implies that, it's an ugly ass arrow. That's better. Okay. Implies that there exists some T such that U ST and T are V. Right? Now, since S, it doesn't really matter, but since S is single rooted, but I'm going to do it in the order of the application of what would be functions if these were functions. We're just going to pretend they're functions. It doesn't change much. Since S is single rooted, we know that for this specific choice of T, U is unique. Right? Similarly, for this specific similarly, given that R is single rooted, this choice no. For this choice of V, T is unique. Right? Oh, I'm running out of space. So let's add some pages, 2 just in case. Now, the fact that WV is an R-composed S implies that there exists some P such that W S P and P S P R V. Do I like P? P is a very ugly letter. Right now. Whatever, we'll stick to P. Okay. I wish we had better variables. But it's okay. Okay. So for this W P for this choice of P, W is unique, and for this choice of V, P is unique. Right? Since R and S are again composed, single rooted sets. Now, we have that for V, P is unique, and for V, T is unique, right? Since P, V is an R-composed S, and TV is an R-composed S, no. Since PV is an R and TV is an R, we must have that P is equal to T. Otherwise, you wouldn't have a unique choice for this value of V, right? So, PV is equal to TV, right? Now, what does this mean? Thus, WSP, that's just lowercase s. No. Yeah, it should be equal. Actually, let me erase this. Sorry. Just to make the flow clearer. So P is equal to T, right? So WSP must be equal to WST, right? Which is if and only if WT is an S. So we have that WT is an it looks like a T. Is an S, and ut is an S, right? Again, S is single. Why is my iPad lagging? S is single rooted, so U must be equal to W, right? And this means yeah, it's not lag on. Like the videos part, my iPad is lagging with the most basic task you can ask it to do, which is literally just writing. I got scammed. Anywho, this means that this choice of U in the domain of R composed S must be unique for this value of V in the range of R composed S. Almost ran out of space there, right? Thus, R composed S must be single rooted. Right? And now, since for any functions f and g are relations, then F composed G must be single rooted, meaning that F composed G must be 1-to-1, also known as injective, which is the term that I prefer, because I always get confused with 1-to-1 and onto. I think they are terrible terms. I think they just confuse me, and I wish that more mathematicians would just use injective and surjective instead. But unfortunately, I have very little say in the math community so far. Eventually, one day, I'll get people to stop saying 1-to-1 and onto. Okay, so there you have it. The composition of two single-rooted sets is again single-rooted, and the composition of two 1-to-1 functions is again 1-to-1. Or let me say that like a functioning member of society. Concluded the composition of two injective functions is again injective. Okay, that sounds much better. Alright, I hope this video was helpful, and I will see you in the next one. Bye-bye.